Hi everyone, welcome back to our Calculus 3 class notes. We're at the bottom of page 98, moving on to page 99. And we're in this example now where we've come across a situation where we need to do trig substitution. So I want to remind you how to do it. When I have a form like this of a squared minus x squared, then I want to let x equal a sine theta. So in other words, x would equal 2 sine theta. If I had had a squared plus x squared, if this had been 4 plus x squared, then I would want to let x equal a tangent theta, or 2 tangent theta. And if I had a situation of x squared minus a squared, I would have had a situation where I want to let x equal a secant theta, or 2 secant theta. But in this case, I have a squared minus x squared, so I want to let x equal a tangent theta, which is 2 tangent theta. I'm sorry, sine theta, x squared, a squared minus x squared. X equals a sine theta, so let x equal 2 sine theta, which means that dx is 2 cosine theta d theta. So I just make those substitutions straight in. So x squared is going to be 4 sine squared theta, and dx is going to be 2 cosine theta d theta. So you can clearly see if I make some simplifications here. So I'm going to factor out a 4 to the 3/2 power. That leaves me with 1 minus sine squared, which is the same as cosine squared. To the 3/2 power, so that's going to be cosine cubed. And then I'll factor this 2 out, put that right here, so I have cosine cubed theta times cosine theta, which is cosine to the 4th theta. So to do that, to integrate cosine to the 4th power, I need to separate that as cosine squared times cosine squared, and then use the identity that the cosine squared of theta is equal to 1 plus cosine of 2 theta over 2. So when I multiply this out, FOIL in it, I get 1. Well, I'll factor out a 1/4 because I'll factor out the 2's in the denominator first. And then when I FOIL it, I get 1 plus 2 cosine 2 theta plus cosine squared of 2 theta. And then I got to use that same identity that the cosine squared of theta equals 1 plus cosine 2 theta over 2. But now it's 2 theta, so that becomes 1 plus cosine of 4 theta over 2. Finally, I can collect the 1 and the 1/2 together to get 3/2. I got all these cosines that I now can integrate. So the integral of cosine of 2 theta is 1/2 sine of 2 theta. So with the 2 in front, just becomes sine of 2 theta. Integral of cosine of 4 theta is 1/4 sine of 4 theta. So that gives me 1/8 sine of 4 theta, evaluated from x equals 0 to x equals 2. So I have to get theta and the sine and cosines of theta in terms of x now, okay? So again, I got some simplification to do here. The sine of 4 theta, how am I going to get that in terms of x? So first of all, sine of 2 theta is 2 sine theta cosine theta. So the sine of 4 theta is 2 sine of 2 theta cosine of 2 theta. Now the sine of 2 theta is 2 sine theta cosine theta, and cosine of 2 theta is cosine squared theta minus sine squared theta. So I'm using a ton of trig identities here. All of this is because I need to get down to the fact that the sine of theta is x over 2. Because remember, we let x equal 2 sine theta. So sine of theta is x over 2. So now I construct this right triangle here to understand what the third side of it would be, which tells me that the cosine of theta is going to be square root of 4 minus x squared over 2. Right, I just used the Pythagorean theorem to fill in the sides at this side of the triangle. And then, of course, theta is sine inverse of x over 2, right, if sine of theta is x over 2. Now I can get everything back in terms of x. Holy cow, but it's a lot of stuff cancels out once I plug in x equals 2, and of course, once I plug in x equals 0. Bottom line is it simplifies to 16 pi. And we will have a much easier way of doing this in section 15.7 when I get to it. Okay, and I'll be back.